All right, so in this video, we're going to use ordinary least squares regression to estimate the coefficients. So we're going to need to import stats models. So import stats models.api as SM. This is going to let us use the stats models functions specifically related to ordinary least squares, or at least related to regression analysis. And now our y, our endogenous, our dependent variable is going to be close price. Our explanatory variable is going to be the square foot. It's going to be the square feet total. Now, whenever you do this, whenever you do the whenever you use stats models, we have an intercept. We have the beta 0. We have the intercept of where square feet intercept is the closing price. In order to estimate that, if we just do square foot total, this is going to be wrong, but we'll go through it. We'll go ahead, and if we do the regression, you're going to have sm dot ordinary least squares OLS. Remember, Python's case sensitive. And the endogenous variable is going to be y. This is the dependent. And exogenous, the exogenous variable is going to be x. This is the dependent, or the independent, or the explanatory variable. We're going to fit the ordinary least squares line. And then let's print the regression summary results. And we get this, but it's wrong. You can see that we have the slope. We have beta 1, the slope of square foot total, but we don't have the intercept. In order to do the intercept, you have to manually create that column of 1. You have to manually create a column of 1s. We use stats models to do it. So we do add constant. This is where we get that constant. So this is the intercept. And what this does is it adds a column of constant. So if we do add constant, we'll give it let's give it square feet total. It creates a column of 1s. This is necessary in order to do the ordinary least squares regression. So don't forget that whenever you go through the project. All right, so now we have our OOS, our ordinary least squares regression results. We have an R squared. Go by that. This is kind of like the correlation. It shows that there's a fit, that there is a linear fit. The adjusted R squared also shows a good fit. And we have an F statistic that shows overall the regression. So look at the F statistic, and here we have a p-value. So what the p-value represents, that is the probability of having this F statistic given that the null hypothesis is true. So please read the statistical learning chapter 2 and chapter 3, especially pages 63 through 72. And this talks about the null and alternative hypothesis related to the regression. So down here, for instance, we have a coefficient of 103. So for every one increase of 1 square foot in the home, the closing price should increase on average by $103. We get a t statistic of 103 and a p-value for that t of almost 0. So for this, I have it up here. We're saying that the null hypothesis is that the slope is 0. If the slope was 0, so if this was 0, that would mean that the square feet of the home and the close price have no relationship. So you're assuming there is no relationship. And then the alternative hypothesis would be that it's not 0. It could be positive, it could be negative, but there is no relationship. So this is the alternative hypothesis, and you're trying to prove that it's not true. So the burden of proof is that there is a relationship. So for here, we have the p-value for that t. So this is the probability of having this t-value, or this t statistic, given that there is no relationship, and it's almost impossible, or it is impossible. So it's you can reject the null hypothesis and say that there is a relationship between the square feet and the closed price of the home. Then it's the same thing for the F statistic. However, this is more overall. And again, we have the p-value for the F statistic. So we're assuming, given that there is no relationship, that this is a bad model, the probability of having this high of an F statistic is almost 0%. So we can reject the null hypothesis and say that there is a relationship. So read the pages from 63 to 72, and that will help you answer the related questions.